Okay, so now we're going to do a proof from scratch, and we want to actually prove that something is a parallelogram. What we've been doing is, here's a parallelogram, prove something about it. Now, here's something about the figure, prove it's a parallelogram. It's kind of like, remember we talked about converses, inverses, contrapositives, all that stuff? Remember, if it's a right angle, then it's 90. That means if we know it's a right angle, then it's 90 degrees. That's the original conditional statement. Then if I were to say, if it's 90 degrees, then it's a right angle, that's the converse. So that's switching it around. I hope I said that the right way. The original statement would be, if it's a right angle, then it's 90. The converse would be, all right, if it's 90, prove it's a right angle. So hopefully I said that correctly. All right, so let's look at this particular proof. So let's start off here. It says DB bisects AC. So I'm going to put one of my givens first. DB bisects AC. And that is given. Okay? So if DB, what it's saying is DB cuts AC in half. It's not saying AC cuts DB in half. It's just saying that DB cuts AC in half. So what I can actually venture on to say is, because DB bisects AC, I know that AE has to be congruent to CE. And that's by definition of bisector. And that's the definition actually of a segment bisector. You could just say bisector, or you can say segment bisector, either way. So now I've established that those two are congruent. So now let's see what else I can do. All right, well, that's not pretty much all I can do with that. So I'm going to come back into red and I'm going to do my given. My next given is that angle 1 is congruent to angle 2. That's given. So I'm going to mark angle 1 congruent to angle 2. Okay? Now, I want to prove this is a parallelogram. There's multiple ways I can go about this. There's multiple ways I can go about this. But I want to try to find the quickest way that I can do it. So there's two things I can do. I can either prove that there's an opposite pair of sides that's parallel and congruent by proving the triangle's congruent, or I can prove that the two diagonals cut each other in half. So either way, I've got to prove that these two triangles are congruent. So how would I continue and finalize this? Again, here's what you have: ASA, SAS, AAS, SSS, HL. So what I'm going to do next is, I see something pretty simple. What are these guys called? Vertical angles. So I know that angle DEA is congruent to angle CEB because vertical angles are congruent. Now, can I say the two triangles are congruent? I certainly can. And which one is it? I've got an angle, a side, and an angle. And remember, the side is included here. This is an included side because it touches both angles. Same thing here in the same sequence. So I can now say that triangle DEA is congruent to triangle BEC by angle, side, angle. So now that I've established those two triangles are congruent, I can establish individuals. So let's look at what I have individually. I can now say all of these are congruent. It depends on what route you want to go. Okay? I'm going to go ahead and say that now DE has to be congruent to EB because of CPCTC. Remember, when we have two congruent triangles, once I've proven they're congruent, that means that I can, sorry, try not to sneeze. That means that I can prove that the other pieces are congruent. So BE and DE are the same. Do you notice what I have now? Well, I can now say that DB and AC bisect each other. Why can I say that? Okay, that's just definition of bisector. You've already established one of them. You already know that DB bisects AC, but now you know they bisect each other. So actually a better way to put this would be that, let me write it in a better way. AC bisects DB. That's a better way for me to write it, because I already have DB bisects AC. Now I know that AC bisects DB. Because I know the two diagonals bisect each other, I can now close my proof and say ABCD is a parallelogram. And the reason for that is the diagonals bisect each other. And I've just proven that it's a parallelogram. Again, I didn't know it was a parallelogram. All I was told is that one segment bisected the other, not that they bisected each other, that's important, and that one of the pairs of angles was the same. Okay, so after I did that, I got the side, I got the angle, and then I used vertical angles to give me my third piece. So I had angle, side, angle, which gave me the triangles. Once I knew all of the triangles were the same, I could establish the other pieces, which gave me DE and EB were congruent. Now, if you wanted to add an extra step in here, you could, that said that E is the midpoint of DB, but I'm not going to do that. And so you say, now you know AC bisects DB. Okay. And the definition of bisector, now you can say it's parallelogram because the diagonals bisect each other.